Hello, and welcome to my video / research idea. I'll get right into it. To put it simply, I'm thinking we should take ChatGPT-4 or Google's Bard to create a unique AI model, one that is specifically designed to correlate case facts between thousands of sighting accounts, images, and videos. It will then apply them to newly described cases to point out details, similarities, and information of note for the user. My idea is extremely similar to a highly effective system the FBI uses to identify serial killers and murderers based on case details when actual evidence is slim. Once created, the model could be used to identify new patterns of UAP activity, to develop new hypotheses about the nature of UAPs, or to generate new leads for UAP investigations. A good example of this and way users could test my idea would be asking an existing AI model about commonly reported details of abductions and then asking it to apply those details to, say, the Dietlob's Pass incident from '59. In addition to helping uncover new information about UAPs, this model would serve as a helpful, unbiased resource of information for those looking to educate themselves on the topic of UAPs and EBEs. Step 1. Data preparation. The NUFORC archives contain a vast amount of data on UFO sightings, including case reports, eyewitness accounts, and other relevant information. Plenty of data that could be applied to relevant and past cases, though it goes largely underutilized due to its vastness, as there are over 120,000 reports on their archives alone. This data is in a variety of formats, mainly text, with some including images and videos. I have personally pored through the NUFORC archives extensively on multiple occasions, and I can assure you it is a painstaking process. To prepare the data for training the AI model, it would need to be converted into a consistent format. This would include extracting text from images and videos using optical character recognition and speech-to-text transcription. Cleaning the text to remove any errors or inconsistencies, such as removing sightings later identified as Starlink. Normalizing the text by converting all text to lowercase and removing punctuation. Labeling each case report with relevant information such as the date and location of the sighting, the type of object seen, the behavior of the object, if this information is available within the report, of course. Step 2. Model training. Once the data is prepared, it can be used to train the AI model. The training process would involve feeding the case reports to the AI model and allowing it to learn the patterns in the data. One way to train the AI model would be to use a natural language processing, or NLP, technique called word embedding. Word embedding is a technique for representing words as vectors of numbers. These vectors can be used to capture the semantic and synaptic relationships between words. To train the AI model using word embedding, the case reports would first be converted into word sequences. The AI model would then learn to represent each word in the sequence as a vector of numbers. Once the AI model has learned to represent words as vectors, it can be used to correlate case facts from thousands of sighting reports and recently described cases. For example, the AI model could be used to find cases where the eyewitnesses described a triangular object or where the sighting occurred near a military base. Another way to train the AI model would be to use a machine learning technique called graph neural networks, or GNNs. GNNs are a type of neural network that can be used to learn on graph-structured data. To train AI models using GNNs, the case reports would first be converted into a graph structure. The nodes in the graph would represent the individual case reports, and the edges in the graph would represent the relationships between the case reports. The AI model would then learn to represent each node in the graph as a vector of numbers. The AI model would also learn to represent each edge in the graph as a vector of numbers. Once the AI model has learned to represent nodes and edges as vectors, it can be used to correlate case facts from thousands of sighting reports in recently described cases. For example, the AI model could be used to find all cases that are connected to a particular case, or cases that are similar to a recently described case. Lastly, both of these techniques are well suited for this task, meaning we may want to consider using a combination of these two techniques. For example, we could use word embedding to represent the individual case reports, and then use GNNs to learn the relationships between the case reports. Step 3. Learning and growing. An important detail we would want in check is making sure the model learns new cases when asking for case detail correlation. One way is using a technique called reinforcement learning. Reinforcement learning is a machine learning technique where a model is given rewards for taking actions that lead to desired outcomes. In this case, we would reward the model for correctly identifying patterns and connections between new cases and existing cases. This would incentivize the model to learn from new data and apply that knowledge to future cases. Some specific examples of rewards that we could give our AI model for correctly identifying patterns and connections between new cases is as follows. A positive score for each correct identification. A positive score for identifying more complex patterns and connections. A bonus score for identifying patterns and connections that are not explicitly defined in the training data, and a bonus score for identifying patterns and connections that lead to new insights or discoveries about UAPs. We could also use negative reward to discourage the AI model from making incorrect identifications. For example, we could give our AI model a negative score for each incorrect identification, or we could give it a lower score for identifying less complex patterns and connections. Another way is transfer learning. Transfer learning is a machine learning technique where a pre-trained model is used at the starting point for a new model. This allows our new model to learn from the pre-trained model's knowledge without having to start from scratch. In this case, we could use a pre-trained model such as BARD or GPT-4 as a starting point for our AI model. This would give the model a good understanding of human language and the ability to learn from new case data quickly. Finally, we can also use a technique called continuous learning to keep our AI model up to date. Continuous learning is a machine learning technique where a model is constantly learning from new data. In this case, you could feed our AI model new cases as they become available. This would allow the model to learn from new data and improve its performance over time. Step 4. Model deployment. Once the AI model is trained, it can be deployed to a production environment. This would involve making the model available to users through a web interface or other API, or maybe a code library. Users could then submit prompts to the model, and it would then return a list of correlated case facts. For example, a user might submit the following prompt to the model. Quote, find all UFO sightings that occurred in the United States in 2023 and that involved a triangular object, end quote. The model would then search through the NUFORC archives and return a list of all cases that match the prompt. The user could then review the list of cases and learn more about each sighting. The model would also be able to search for and then apply relevant UAP facts from accounts to cases not commonly attributed to UAPs, like for example, chupacabra killings or missing 411s. Some benefits of using an AI model to correlate case facts from UFO sighting reports include AI models can process large amounts of data leagues faster than humans. AI models can identify patterns in data that humans might miss. AI models can be used to identify correlations between cases that would be difficult or impossible for humans to find, harking back to the 120,000 reports. AI models can also be used to generate new hypotheses about UFO sightings and cases. But some potential challenges might be ensuring that the AI model is trained on high-quality data, with it being able to properly distinguish between misreported sightings such as Starlink and legitimate UAPs worth investigating. Another challenge is ensuring that the AI model is not biased towards certain types of cases or data points, leading to skewed responses. Finally, it is important to be transparent about the limitations of the AI model and to make it clear that it is not a replacement for human judgment when it comes to UAP research. In conclusion, the development of an AI model to correlate case facts between thousands of sighting reports, images, and videos is a groundbreaking idea with the potential to revolutionize the field of UAP research. Such a model would be able to identify patterns and connections that would be impossible for humans to find on their own, leading to new insights and discoveries about the nature of UAPs. Let's share this video with others so that we can raise some awareness, get the ball rolling. Together, we can make this AI model a reality and accelerate the pace of UAP research.